All right. Can I start?
Yes, yes, please.
Okay. Okay. Welcome back, everyone. I hope it was a good break for everyone. Um, I just pulled up, like in the break, I just pulled up some examples based on feedback from everyone. Just wanted to show if even like this is just now, I asked ChatGPT 5, 7 artist names. So now they have kind of tuned it to say these are 10 famous artists across history. And then it asks, like, do you want to focus on more things? So they're trying to reply by being specific. Earlier you would just ask, and now there's one name, Frida Kahlo. And now if I ask why mostly male artists, then it's explaining much more confidently because, it's saying lean heavily because that's how history has been. There's been a lot of bias. So that's where it kind of comes from. And now they've kind of, put in more data to tell it why does it say like this, and speak more with more clarity, like I'm giving you famous artists, not just artists. And then one more bit I wanted to share about tokens is that we talked about tokens, right? And I showed you how you can give an emoji and does not understand. So this is a super famous example. Like you ask ChatGPT how many are in strawberry. I'm sure a lot of people might have seen it. And then it will say there are two R characters in the word strawberry because ChatGPT does not see strawberry as individual tokens. It's individual characters. It does not see STRAW. It sees maybe STR and then AWBERRY. Maybe it sees straw and berry, and it knows though they have R's, so it just says it has two R's. And then the person is asking, check again, will you bet? And then it says, yes, I would bet everything. So you would have seen that in the first version of ChatGPT. This was in ChatGPT 4 as well. And now they have managed to, do away with this. Another example. So this is, an example where, this also introduces risk, right? You can't depend on it because you trained it with tokens that did not break it down into individual characters. So this is where you introduce risk in it. There is where you have your model which can break down easily, right? It's such a simple question. Like it's so simple, right? And then there's another example where someone found out there is a token where a special token called solid gold Magikarp. So very weird. We don't know how it happened. But there's a solid gold Magikarp token. And if you ask a question, what does this mean? It kind of just thinks it means distribute. Because in the training data, solid gold Magikarp probably didn't appear, like this string did not appear often. They were not very careful about this token in their vocabulary, and it somehow probably ended up closer to distribute. So ChatGPT thought this means distribute. So you could say distribute, and then you can ask it to do very weird, bizarre behaviors and something like you can just use this to say to make ChatGPT say anything that you want, basically. So this is the kind of ways people do prompt injections, or just prompt engineering to make model behave in undesirable ways. And there are also, I don't have time to pull this up, but there are examples of making, for example, I have a airline company and I just use ChatGPT to talk to my customers. A customer can say, use solid gold Magikarp and do something, and then my bot can promise some deals or undesirable things that I don't want it to say, but uh, customer has figured out a way. So need to be careful when deploying or using AI models, that there are some ways that they can break. We'll go into more depth later on. What is referred to as model hallucination? So there's a question, what is referred to as model hallucination? To be honest, so model hallucination is an older word. It's a very fun question. The way I personally think about it is that all of this is hallucination. Uh, because it's just coming up on, you're forcing model to do something, create something. So it's just coming up with things. But technically, hallucination means um, when the model says something um, that is not factually correct, or if it's more subjective, then you would say if it's producing something undesirable. So for example, this would be a hallucination when you're asking about the string solid gold Magikarp and it's saying distribute. Or in the previous example, when we were looking at strawberry and it was saying two. Those would be hallucinations. Okay, now back to slides. So my question is then, we're just predicting the next word, right? And we are doing it enough times, but why does it work? Why this is such a simple thing? Just predict the next word. Literally every language model is doing that. So why did it become so powerful? Why does it understand everything that we are talking about? So this is because when you choose your next words carefully and you force a model and you're training the model to predict that, your model is kind of forced to understand the context around it or the nuances or the semantic meaning. So we talked about how we train a model using carefully selecting our data. We talked about how embeddings are supposed to be representations or capture semantic meaning. Um, so when we train the model to predict the next word, the representations are supposed to capture the meaning for that word itself. So if you were to say, peanut butter and so jelly, so that's common sense, and you're training on scientific data. So if you're just completing sentences, it's kind of trying to understand, okay, photosynthesis, sunlight, water, CO2, they kind of go together. And if you give more examples, it will understand how these three words interact. If you drop a glass, it will likely break. So that's it's trying to, getting physics or real world common sense. Too much sugar can lead to diabetes. So that's like a health example. And you can imagine, I take all of the text in the world, all the text on the internet, and just train on it. There are probably a lot of books talking about photosynthesis or just people talking about photosynthesis in very different ways or making jokes about it. So language model will pick up on these nuances by just predicting the next word and just works. And that's the to me, that's the simple beauty of these language models. They're just trying to predict the next word. It is such a simple task. And a lot of people also think about, we personally as a humans also predict, but I won't go into that discussion. Um, and the most important thing about it is that this kind of just works at the scale. We have had these models since a long time. We have had language models predicting the next word for a couple of years. But as you can see in this graph, they kind of just work on different evaluations. As soon as you start scaling the number of parameters and you start giving more data. When I say parameters, I think a good way to look at it is like these kind of interactions. What is the size of your embeddings? That is some parameter. How big is your, these matrices or so on. So these model has some parameters that go into it. So if you start increasing these parameters and the amount of data that they see, um, it's kind of, I believe it's kind of intuitive as well, right? If I see more examples, the better I am at predicting things. So it kind of works similarly with language models as well. And you can see that this trend is kind of not. So there's another paper, actually, I forgot to cite it, but there's another paper which shows that we are still not at the limit of saturation. We can still throw more data and more compute. So which is why we still see, news articles like Meta is building data centers with the size of Manhattan, like a whole city. That's the size of the data center. And Google is trying to use nuclear power to, power these data centers because they consume such high energy, and those energy are not even possible right now with the current US grid. So these companies are now forced to make nuclear power plants. Um, that's where it's getting at. Okay, so now let's see. We are able to predict next word, but that's not actually how you or me interact with ChatGPT day to day, right? We type a full sentence, we send it to ChatGPT, and it gives us the full sentence back. So this is a good layout by OpenAI, how they see we go from language model to a fully AGI world. I added this level 0, which is what we talked about, which is the foundation model. So what we saw before was how a foundation model works, how a simple language model works. But then you have to convert it into a chatbot. So that would be level one, which is what ChatGPT, Claude, Gemini in their basic form are. So this is like an article for level zero, for example. I think this is GPT-2 in 2019, and they said it was too dangerous because it's just a text generating AI. I think there was a question about it generating large pieces of text, right? So I use a generation, I just ask what is the, and this is all generated text by just predicting next word, next token. You can keep generating anything. But now we want the level one chatbots. As I talked about, yeah, these are ChatGPT, Gemini, Claude, blah, blah, blah. So what happens is now we take any regular piece of chat and we convert it into a string like we saw before. So for example, if I have this chat between I can actually show an example. So if I have a user question, what is the color of the sky? So as you can see, this is actually what gets sent to the language model. So these are some special tokens that ChatGPT or any company would put to separate out, okay, this is a user question. A user is asking me this question. The user question has ended. Sorry about this, yeah. And then there is an assistant question. So assistant is now supposed to start, right? And this is what we would probably put it. I don't know if it will work here, but I hope this gives you a full picture. Yeah. So this is kind of where it will, yeah. See what? So this is the kind of full picture now. So when you ask a question to ChatGPT, or Gemini or Claude or Llama, it converts it into a different kind of format, and which is actually just a single one-dimensional string. And it passes to a language model, which then generates tokens one by one. And oh yeah, my bad. Let me share the link to the tokenizer for people to play around. So it converts this into this one-dimensional string, goes back to the transformer, it keeps generating tokens, and when a language model is finished, it comes back to you saying sky is blue, and then you ask a question, why is water blue? And then it goes on. And here on the right hand side, you can see how these are actually individual tokens, right? It kind of breaks down, these colors kind of represent each separate token. And these numbers just represent the embedding, nothing else. And here you can also see how, so there is a question if we can control the tokenizer, right? As you can see, each different model has a different tokenizer. So whenever they train it, they choose how they want to use or how they want to split each word into tokens. So for example, Code Llama, oops, kind of resets, my bad. I mean, feel free to try different models. So for example, GPT-2 would have something else. Oh yeah, GPT-2 was not a chat model. So why is sky blue would just be the text. But then we have chat models like GPT 3.5 Turbo, which is why we have this. As you can see here, actually, the embedding is probably different. Maybe between Llama or Gemini or Qwen, these embeddings differ. But I hope it gives the idea of how we actually use those simple next word predictors as a chat model. We can spend some time here, play around how tokenizer is working, or we can go to the next step. So the first step was to take this chat to take this, new way of interacting with the language model and making it work with the next word predictor machine that we saw before. So we were able to get that working now by converting chat into this format, right? And then the problem is now that we need to show examples to the language model in this format now, because language model has not seen it. This language model was trained on all the text in the internet. It has not seen enough examples of interactions or text in chat format. So this is where the, oops, wait a second. Something happened with my slideshow. Give me a second. Not bad. Okay. Oh, it's clicking on the link. That's why. Okay. So this is where we next. So we had a fully functioning language next token predictor, but now we want to make it work with this chat. So we fine tune the model. What fine tuning means is you take a huge pre-trained model and then you fine tune it on some smaller number of examples for to make it behave the way you want it to. So this is where actually I'll introduce the term like GPT is generative pre-trained transformer, because it is a generative model since it's predicting the next token. So this is called a generative model. It's pre-trained because you used it on a huge number of huge piece of text, and it's a transformer model because that's the name of this model that you see here. And when you're using it in chat, you fine tune it on a smaller set of chat examples. So what a big company who's working on foundation models would do is, after that pre-trained model, they would hire a lot of people who, give out examples of good conversations like we saw in the chat before. Um, uh, okay. What is happening? Okay, my bad. Yeah. So they would fine tune the language model on good examples of chat. So any chat you have with Chat GPT is kind of how they would have humans annotate. Like if I ask a question, they will have humans say what a good answer looks like. I think you would have also seen whenever you use Chat GPT, it will give you two options, which is good, which is bad. They kind of use those signals to select good examples, good answers. So this is where they are fine tuning it. And this is where also the alignment question comes in. So when you're talking about alignment, this is a good chance, since you are, fine tuning the model's behavior to behave in the way you want it to. You kind of want it to align with the tone and personality you want it to have. So there are um, two kind of way to align it. You can control the kind of personality it has. So you would see between different language models, they talk to you or interact to you different ways, because each company or each lab that is training that model has their own idea of how a chatbot would interact with a human. So that's where they would, collect different examples or different training data with the tone, format, role, and all of them also have different ways of, controlling the safety. How do you refuse harm? How do you be honest? How do you follow rules? So like I have links here, but we can, like, for example, Claude has its own constitution. They list out or like describe what safety means for them, and what they have they have their constitution is basically the core to their model. where they talk about, a model should be honest, a model should be harmless, and how they collect data to ensure that that is represented whenever anyone interacts with their model. For example, similarly with ChatGPT, if whenever there is a new model released, they will have detailed safety reports describing, what is the likelihood of someone jailbreaking ChatGPT to, for example, create a bomb or all those sensitive content that should not be accessible, and models should be refusing. So this is where you have a good lever to control behavior. And then, so wait a second. So this kind of describes the level 1 of it, where you have a chatbot. Any questions again, as before, let me know. And then the next step is reasoning models. So just producing text is not sufficient. You want to be able to reason, to solve complex problems. When any of us solves any mathematical question, if I say 2 plus 2 equal to 4, then that's like intuitive because you've seen it so many times, it's intuitive. So that's level 1. But if I say like multiply 212 into give me 434, then you'll have to probably sit down and write and go through a series of steps to arrive at the answer. So this is similarly what you would expect with the language model as well. So that is the idea why we are trying to go for reasoning models. As you can see in the news, these language models are now able to get gold medals at math Olympiads. And this is, I think, at the time of caption 1 month, which is like 2 months old news. So what is happening? How are language models able to reason so well? So the idea is, as I said before, instead of having the language model answer a question directly, you explicitly ask it to reason. You explicitly ask it to think. That you will say, for example, here you give it an example. Like, okay, given a question, I thought about it, and then I gave the answer is 11. So for a new question, you ask the model to think about it, and then you are given the answer. So this is similar to what you will see when you use ChatGPT now, or any language model. When you ask a question, you will see it's thinking and collecting data, doing blah blah blah, and then it gives you the answer because you want to make sure it arrives at the right answer. So this would have been a hallucination, right? We have talked about hallucination before. This is more where model is getting wrong answer. But the same model, by prompting it differently, we change the probability distributions, asking it to reason through this. When we ask it to reason, the model has kind of, broken down the problem. And now since it's kind of reasoned through it and arrived at, it's thought through it, it saw 3 plus 6, 9. And then, when it generates next token, it has the answer. Now it knows 9 is the right answer. So it'll have high probability of saying 9 instead of this just being the prompt and arriving at a probability of 9. I hope that makes sense. I'll repeat that if to simplify. So we saw prompts control the probability distributions, right? So if we just had this kind of a prompt with a question, the probability distribution for 27 would probably be low. But if you ask it to solve it, it's more likely to think through the problem because people explain things in the world. You have text explaining things. And the model is more likely to arrive at higher probability for 9 because it has these tokens to increase that probability and solve the answer. So this method is called chain of thought prompting. It was very popular in 2023. And we had only vanilla ChatGPT, so that's what we used. So we used to explicitly ask, think before you answer. I think that's very popular idea. This is where it comes from. And now it's kind of explicitly baked in. So when you use ChatGPT, it kind of just thinks out of the box now because reducing hallucinations and solving complex problems. So this is an example of model. So x-axis would be, you allow it more time to think, and y-axis is math test accuracy. So as you can see clearly, the more time you allow it to think, the more likely it is to answer the question. So this is called inference time reasoning. Yeah, that's one of the most popular ways to address hallucinations. Um, and then the next step is agents. Qualitative example related to society. So the question is a request for qualitative example. So qualitative example would be, I think this is a safety approach, in my opinion. If you um, have a deployment of your agent, I mean, we face it when we are using language models every day in the industry as well. For example, we when we were building cybersecurity agents, for example, and we were just throwing data at it. Model does not understand what to make of it and how to correlate it with my question. So you would ask explicitly ask model to think and solve the problem before giving me the answer. So what happens is you increase the chance of it get solving the problem, and you reduce the risk of it generating a harmful or wrong answer. This is also where you can ask it to think before generates any harmful content. For example, if it's like, if that's what your application is about, this is where you can ask the model to think, hey, this is a checklist, for example. You would ask it to say, uh, make sure you're not predicting any harmful content, and think and verify against the checklist and then answer a question. So this is where you can control those kind of behaviors. Hope that helps. I mean, hallucination is very, very risky and very important topic for all applications, for all real world applications at least. And this is like one of the most effective ways to reduce that. And all of the wrong answers here, as you can imagine, were actually hallucinations. So like if it was not getting good accuracy because it was hallucinating. So the more time you gave it to predict the right answer, the less it was hallucinating. Um, okay. So the next is agents. Agents is where you let language model take actions. 2025 is famously called the year of agents in the industry, at least, because and I'm sure everyone has seen so many cool agents pop up, like Cursor, Lovable, Manus, and even the ChatGPT agent mood, and Deep Research itself is actually an agent. Um, what happens, what are agents actually mean? So will get into a activity around these agents, but let's first understand what does an agent mean. We have talked about chatbots, we have talked about reasoning models. Now let's understand what are agents. So when you look at an agent, there are four main categories. This is a slide from a blog by Lillian Wang. So we talked about planning or thinking. So for example, you can just correlate it with maybe a robot or like with yourself in a new environment. So if you're in a new environment and you're trying to do some activity, you would have to think about it. You would do the activity. You will memorize what worked, what did not work. You will reflect, like we talked about what worked, what did not. Whatever worked, you store it. What did not work, you probably throw it away, and then you repeat. So any agent in a new world or a new environment would act on the environment. Depending on the actions, it will memorize what worked or memorize things about the environment, and then it will plan how it wants to interact with the environment. So for a chatbot or for an AI or LLM, what it would mean is you want the LLM to think or use chain of thought, for example. You want the language model to have tools so that it interacts. We just talked about token producing machine, but how does it interact with these things? And you want it to remember, because if you start a new session of ChatGPT, it does not know anything now. So what happens? How can I make it remember things? So this is where, let's first talk about tool use. So for example, I have to ask question, what's the next talk today? So model actually in itself does not know that, right? but can I get it from somewhere? So it will say, okay, why don't I have a calendar tool? I can check what's today. So it will call a calendar tool. When it calls a calendar tool, it just, spits the string, says, for example, it will say calendar next talk. And we programmers will make sure, like whoever designs the agent will make sure we call we get the data from this LLM call, and then we give it to the language model. That's how tool call kind of works. Language model says, let me check the calendar tool. Someone checks it, and then it gives it back to the language model. And then the language model responds to you saying, I checked your calendar. The next talk is this from this minute. Any questions? I want to take a pause at tool call because it's a complicated topic. A lot of people don't get it. I've seen, so I'll repeat this idea where whenever we say a language model or whenever we say AI is calling a tool or using a tool, it is specifying what tool it wants to call, as we see here. Let's check the calendar. And then the tool is just like a piece of code. That piece of code returns the answer saying this is the next talk. And then your language model is able to answer because I fit all of this in the prompt like we see here. The next talk is, I think there is a system, yeah. Okay. Okay, so that's tool use. If any questions, please feel free to drop in the chat. Memory, similarly. I think we talked about so the question is, are you saying the agents have the ability to do internal monologue before agents models couldn't do that? So the internal monologue is kind of for the representation purpose. I've kind of simplified things. But what would happen is, let me see if I can show in ChatGPT. So if I see, ask what is the weather today. So this is when it said searching the web. I mean, it just happened too quickly. It was calling that tool. So that would be an example of the internal monologue for per se. I can't see the history, unfortunately. So as you can see, we are not able to see the searching the web or what did it search, right? They have decided to hide it away from us. So that's what I'm calling the internal monologue. But the language model says, okay, I have the, for example, weather, or I can search Google, and it will search Google. Someone will execute that code, give it the answer, and then it will produce the answer. Like ChatGPT does not have the weather today, right? But it got it because it called the tool. Hope that makes sense. Like this is an oversimplification of the things that happen behind the back. But the idea is model specifies what tool it wants to call, which is just code. Like model specifies what code it wants to execute. Someone executes that code, gives back the answer, and then the model produces the next thing. Next is memory. Sorry, this part of the class is very dense, but it's like a lot of important concepts that I wanted to take away. So we talked about the context right here. Like someone asked, how would the model work with 10,000 words? So that's called the context window. You can keep adding more and more things, but it doesn't work. It stops working so well after a long time. I'm sure everyone has faced problems when the chat becomes too long and then you have to start a new chat because the memories, there's like so many tokens it can store in the chat. So that's the memory within an ongoing chat is, you can think of it as a short-term memory, right? And then if you want your model to remember across chats, then you'd want a long-term memory. So what the real world example is, if I have an application that people use to book flights, and every time I have a user coming in and they have to specify, oh, I like, flights in the morning, I like this, I like that. And if every time a user has to do that, then obviously they won't stick around because your bot does not remember it. Your bots are supposed to be smart. So you would want to extract that information, from an ongoing chat. You would extract, they like early morning flights, they like, cheap flights, they like expensive flights, blah, blah, blah. And you store that information. You store that information in some sort of a memory bank. And whenever they come back, you retrieve that and you maybe give that back to the LLM in the internal monologue or something. And then you let the language model generate it. So this is where you engineer the context. This is now being called context engineering, for example, that I extracted some pieces of information from older chats or the world and organize that into a smaller piece of text, put that in the prompt or the context, and let model generate. So now when I come back and generate things, ask a question about flights, the model will be more likely to say, oh, these are some even morning flights that I found. And the user would have a happy experience with the app because now the bot remembers. They don't have to say everything every time. If I go to book a flight on Make My Trip or Google Flights, every time I have to put on the filters. But if they were always pre-filled, that would be a much seamless and faster experience for me. So that is the core idea behind why we need long-term memory. And a good follow-up question could be like, how do we store these memories when there's a large amount of memory bank? Again, embeddings. It's all text, you store it as embeddings. Skip this. Let's skip this. And yeah, so the next step right now, as laid out by OpenAI, is agents which can innovate, or AI which can innovate or create new ideas. Because now we have reasoners, we have agents that can do things, collect data from the world, act on the world. Now they should be able to invent new things like humans do. And we are starting to see some glimpses of that already. There is AI which can generate new proteins. There's literally this year, Google mentioned that they have their AI which is designing advanced algorithms. There's a new matrix multiplication algorithm that we discovered using AI or reinforcement learning that we mentioned before. So there's already glimpses of innovation coming in from leveraging all these AI models. And you can see this is like a 2022 article. And there is also like AI is continuously leveraged into for protein synthesis and coding right now. LLM shortcomings. I think I'll skim over this because I want to get to the next activity. So everyone is already aware of hallucinations because it answers gives wrong answers confidently. We already talked about the strawberry example. Like it's very obvious to us, but LLMs can make mistakes on very simple things. As we talked about, the whole idea of long-term memory is because it does not remember every new experience because we start from a fresh new chat window. So it does not know. It has no idea what happened before. And then it's easily tricked, as we saw. We can just say, oh, you are this now, and act like this new behavior, and then it will start acting this way because it's again just prompt. And the prompt is used to control the model behavior. So let's get into the activity. So I have two activities here, depending on how crowd wants to go for it. So one is I just want, based on everything we talked about, LLM shortcomings, how do you make an agent, what is the path to good agents or AGI, depending on OpenAI's layout. I would like all of us just go to ChatGPT and just see what kind of tools you think ChatGPT has. Where are the levers? What kind of how do you think memory is being used? Where do you store memory? Or where is ChatGPT controlling the system prompt, for example? I think we can control temperature somewhere as well, probably. But yeah, I think there's options for thinking reasoning models as well. So just like take some time to explore around, ask me questions, um, discuss among yourselves. And there's also the next activity from let's just go to manus.im/use cases case form user. So this is a, I will say, precursor to this agentic ChatGPT. They have a list of examples. These examples are for questions like create online 3D gallery for Van Gogh paintings. And you just gave some photos. And here the language model, you just let it go. This is like an agent where it collected paintings, analyzed them, set up a project, so it wrote some code and executed a lot of commands to host it. And after all of this, it has this website where you can see these in a 3D environment. And you can even see the replays as well. Watch again. So you can see the model act out. So here it is doing this, writing a lot of code, executing this. So here, as you can see, this is a task progress. It has planned out. These are all the tools it is calling. It remembers everything in the memory because it's a huge context and they have, compressed information to feed it. And then it generates this code to host the website. I tried it before the presentation and asked it to generate slides for GenAI fundamentals. So I just asked, create slides for a course on GenAI fundamentals. And it searched, it browsed. I'm just, by the way, you don't have to wait for me. Feel free to explore around, use ChatGPT to take the time to break it down, ask me questions, or go to Manus, try any of the use cases. I'm just explaining while everyone discusses. So it goes and actually browses the internet, search for images, and then it generates this slide deck. So this is the slide deck that it generated for GenAI. And I promise my slides were not AI generated. But you can see how it did. Course overview, introduction, prompt engineering, foundation models, impact, it generated even, there's code for each of this. So when it generates a slide, it's actually just HTML code. It's just like, website code. How did it get this? It did not just spit it out from its own memory. It actually searched Google and went to websites to collect that information. I think we can see in a replay. But yeah. And if you go to this website, you will see a lot of examples, wedding invitation, budgeting calculator. You can make apps, you can deploy apps. Even if you go to Gemini AI Studio, it's very similar. Let me know if you're not able to access Manus, by the way. And I hope I don't need to give ChatGPT link. Also I can take some time for ChatGPT as well. If you go to settings, you will see personalization. There's like things about memory. You can manage memory. It will, have those pieces of information stored. When you actually talk to ChatGPT, it has extracted that information. So you can go see yours. Like I have a fresh session here, but you can see your ChatGPT instance, and you'll have a list of things that it has extracted and remembered from when you used it. And that's how it is using, and it remembers things about you. It can make mistakes there because it does not know what is a good thing to remember. So that's where it can make mistakes. For example, if I keep talking about, like, I had this personal anecdote, like I kept talking about, I was working on this project, I was generating a lot of slides and charts. So I kept asking ChatGPT, about how do you make slides, how do you do this, do that. And then 1 week later, I asked ChatGPT, what do you think about me? And then it said, you are someone who likes to create slides. So, but that's not all who I am, but that's what ChatGPT thinks of me, because that's what the memory was. You can also kind of customize ChatGPT here with this personalization, which is just, again, prompt. They fill this form, put it in a text format as a prompt, and then it's just prompt, nothing fancy happening here. This, again, deep research is a tool, web search is a tool. So if you do web search and you say, I don't know, weather in Peru today or tomorrow. I mean, there is no way a language model actually knows this, but you would just search it and just search it and give you the answer. So yeah, the search is one example that I showed you, but there are more tools. So I would like people to figure out what other tools ChatGPT has. Kind of giveaway. And if everyone has, like, anyone sees these kind of connect options as well, these are also, options to add more tools. So, if you connect Google Drive, it just, adds those tools to ChatGPT and it works. Can think I have ChatGPT Pro as well. It has, this, as you can see, thinking model, and thinking model is different than the regular model. And the agent mode is also very similar to the Manus one that I showed before. But maybe you can try agent mode. Let's see. Any question? Let's see, again, create slides for Gen AI course. Maybe you can try with the Manus one as well. Try something similar or something new, make a website. I don't know, you can keep trying. So here, ChatGPT is asking me something. Yeah, this is all free to use. Manus you should have free access. Like, I haven't paid for anything. There's some free credits, 1,000 free credits. So you should be, just sign up. Yeah, you'll have to sign in, use your account, and it should have like 1,000 free credits. So we should be able to make some smaller apps. Yeah, and if for some reason, if you're not able to work with Manus, just feel free to just explore around ChatGPT. I just let it continue. I'm just showing an example of the agent mode. It's reflecting I have used credits. Can you try with another email ID? Computer audio. Oh no, this is not. This is what I'm saying. It's actually opening links and using that. There's no audio. This is not a video. This is like ChatGPT actually going in and doing things like tried in 2 IDs. Is everyone having the problem with Manus? Because I tried with a fresh ID as well. what you can do is, instead of creating, at least you can go to these use cases. You can click on any of these and you can see the replay. If it is not working, so you can click and see the replay of how it actually worked. So you'll see the steps one by one. So I would like you to see like what kind of tools it's using, and just try anything that you like from here if it is not working for you. I wish I could share the credits, but they have not exposed the language model. See here, ChatGPT is opening like it's opening some file, reading things. I'll just let it run here. So actually what's happening is people have just realized that since we can give tools to an AI model, why don't we just give the terminal? So why don't we let model execute code? So what people do is just make a small isolated maybe machine or like a laptop, and this is let it execute code. This is literally what ChatGPT is doing right now. It is literally writing code and it's saying, okay, I'm going to do this, this, this. We'll keep doing that, and then it'll give you the answer. Are you able to access the replays? Even questions? Anywhere there's stuck, let me know. See, it's trying to generate a PowerPoint file now. But yeah, the tool use is basically just telling it what, for example, this would be, oh, it went away. Okay. Tool use example, maybe I can show here. So for example, in code, so whenever you're writing code, you would have, maybe you have a function which says, get weather and the city. So this is this you kind of tell the language model that you can call the weather, and you'll have the model will specify what city, and the model will execute and give you the answer for that. So that's how kind of tool use works. And when you give Google search, it kind of also just works like that. Google search and so on. Let me try if Manus works, doesn't work. And since we are short on time, let's see what did it do. Oh, ChatGPT created slides. Gen AI Foundation. Oh, it went into image model. Nice. That's our next topic. What is Gen AI? GANs, AI diffusion models. We already learned about transformers, diffusion is next. Yeah. Any questions? Chat, online participants. Okay, in favor of time, I hope the idea of agents, memory, tools, planning is clear. That would be the most important takeaway. This is an example of the plan. These are the tools that it called. All of these are just tools, and just letting a model plan, execute tools, and remember things helps you generate something like this. How do we switch out? It's probably out of scope for this fundamentals class. But we can move on to what ChatGPT recommended as a generative AI model thing, which is called diffusion models. So we've talked about text all this time. I just wanted to take some time to talk about image generation. I'm just gonna hold everyone for 10 more minutes. So currently we see models being super good with image generation, like this Sora from 2024 image, but it hasn't always been the case. Models were choose as was like chat mode that is free to use. You can create slides, etc. with that. Okay. For people using Manus, there's a chat mode that you can select, which is free to use, and you can ask it to create slides. So I'm glad that people got it working. So that's good to know. Feel free to play around with it later. It's a very cool tool, very helpful, very fun. For image diffusion models, I'll just quickly breeze through it. So how does image diffusion work? I can give me a second. Sorry. Okay, give me a second. Sorry. Okay. Okay. So we saw given enough training data, we can train a model to generate text. So similarly, it works for images as well, right? We just given enough data, we can ask a model to generate images. So the latest models that we see in the market right now are called diffusion models. They work in a very interesting way. Unlike the language models which predict the next token, these models actually just start from random noise, literally random noise. And one by one, they develop the image, or, from noise, you go to an actual image, much like how a Polaroid is developed. But here, you kind of start with some text, convert that text into embedding, and that embedding guides this denoising process. So you start from some noise, you denoise it one by one, so slowly, to get an actual image, but you use a text embedding to guide this process. And since it's an embedding, and we saw embedding can be anything, you can also use an image to convert that into an embedding and use that to guide the diffusion process. This is where you will see, you give styles, or, you give an image, you ask a model to edit part of it, and so on. This is kind of oversimplification of how it works. There's this another concept of, in painting, where when if you've seen that erase options, these more like you can, erase people in the background. This is kind of how it works. You train a language model to fill in erased parts. And then we have also seen how models can, increase the size of image or expand the image. This is how, like, you just reverse the in-painting part and just, you ask the model to fill in the remaining part. And for this, it's very simple, right? You just collect a lot of images. You can block out different parts, and you can keep asking the model to generate, more and more. So one image can give you many data points, and more images will give you more data points. Similarly, video generation also kind of works this way.
Here's what it looks like.
Not
From here, this pure noise video is passed into a transformer. This is the same type of AI model used by large language models, like generated video that looks 10, 20 noise into 30,
and you just
40.
video diversion. So yeah, I mean, it kind of works similarly with video as well. When with images, we were doing one image. With video, we give like all frames, all video frames together. So you can imagine maybe like 50 photos, and it's denoising 50 photos at a time. So that's why you can imagine why it's more expensive. If you have ever used APIs for video generation or use any app, these are more expensive because they are doing more compute, they are using more frames and then denoise that.
Here's
Look at video generation next. Do we have time for activities, or I think we at the end of time, right? I'll just drop the links for people to play around with. Basically, yeah, this is just like popular tools and some diffusion explainers. Some more models that we probably not see everywhere. So this is like a repository of different kinds of models. Then I'll just conclude saying, so we talked about data. There's, more data means better models, but we are reaching a limit of the total text in this world, because that's like finite. And as you can see, language models are already reaching that limit. So how do you train model with that ceiling? You use synthetic data and you use data from physical world. Like when a baby is born, they interact with the world in different ways and they learn about this world physically. So that's how you can also train models. So there's active work on training a model using three-dimensional or more dimensional data, so that it understands nature and physics of the world. And there's also very interesting things like we saw diffusion models for image. There's also like text diffusion models are coming in. So there's a lot of things happening. The ceiling is not yet reached. So that's why it's very exciting times in the industry. There's risks and about these actively being addressed. All of this is very active field of research. And that's it. If you have any questions, you can ask me. There's a little QR code. I would really appreciate a little form for feedback. So you can fill out, let me know how things went, what worked for you, what didn't work for you. Yeah, I'm happy to take questions.
Online participants, are there any questions from your end? I think I speak on behalf of everybody joining here physically as well as online, that this has been a very power-packed and learning session in terms of the hands-on activities also that we did, and the fundamentals of AI that we learned so far. The terms that usually haunt us, like hallucination, diffusion, embeddings, we sort of skim past through them, but now after the session, we have much better understanding of them. So we'll just wait for, let's say, 5-7 minutes in case anybody has questions. Otherwise, we'll wrap up.
Yeah, thank you so much. Yeah. And yeah, I would again appreciate we can fill the feedback form. And yeah, I know we powered through a lot of things, as Nidhi said. Yeah, these are like I could go on infinitely about each of these topics, so it's tough to compress. But I hope the gist went through, and I hope that given a new AI app, you are able to break down the individual components and are not, carried away by the buzz they throw at you. That's a, industry thing, and it's important to understand how things work. Ooh, cool.
Shantanu, we'll just take a group photograph with you. So
Okay.
you can stop sharing your screen and put yourself.
Oh yeah, let me stop sharing my screen. Right.
On this camera. But Shantanu, okay, I'll take the twin screen. Online participants, you're requested to also join in the group photograph with us. Is this it's been
Is anyone saying cheese?
Thanks a lot, Shantanu. Just for out of curiosity, what time is it there in San Francisco at the moment?
It's 12:10 now. 12:10
Oh my
a.m.
God.
It's
It's
all right.
exactly
I have to
12
go
hours
there.
behind us.
All right.
Great.
Awesome. Thanks everyone.
Thank
Have
you.
a
Thank
good
you for the
workshop.
lovely session. Sending big thanks from India.
Thank you. Bye bye. Good night.